And I work for NRK, the Norwegian state broadcaster. I work on the NRKTV team, which is the team that develops our streaming services. And we develop everything from the APIs to our desking tool to our front-end clients. And today I'll be talking quickly about how we quality control our Android and AndroidTV clients using instrumented tests. So first we should quickly look at what our applications actually look like. Our applications are quite complex. We have an editorial front page, we have series pages, we have categories pages, search, personalization, and we have two different kinds of players. We have the live player and the on-demand player. And the Android and the Android TV applications actually share the same code base, but they're quite different in their UI. And this is obviously because of screen size, but also because of navigation. On mobile, you use the touch, while on Android TV, you navigate with a remote control. So with a complex app like ours, it can be very hard to maintain our quality as we develop new features or fix bugs. And then manual testing sessions are not enough to find out if we broke something. Instrumented tests are important in our quality control. We also have regular JUnit tests on both unit and integration level. However, we frankly don't have very good coverage. And so our instrumented tests are the ones that cover most of the functionality of our app overall. So onto what instrumented tests actually are. So instrumented tests in general terms are tests that run on a real device or on an emulator. Most often these will be UI and system tests. However, you can also run unit and integration tests this way as well. And that's mostly in cases when you can't easily mock the dependencies for these tests. So any test that runs on Android runtime, as opposed to locally on the JVM, is an instrumented test. And you might also notice that the local tests use JUnit, while instrumented tests use Android JUnit Runner. And Android JUnit Runner is actually an instrumentation implementation, not JUnit. And it runs JUnit 3 and 4 tests against the Android package. And also by default, Android Studio will generate these two different file paths that you can see at the bottom, and your Gradle will automatically know that if something is under Android test labs Java, that it should run it against a real device or an emulator. The instrumentation framework provides a special test environment that runs the test APK and the APK under test in the same process. The instrumentation can then set application state before you boot up your application by setting mock system objects such as contexts. And you can control your applications at various states during runtime. You can send UI events to it, and you can examine its state during execution. Early in the process, when we were talking about what we wanted out of our instrumented tests, we thought that writing simple UI tests was sort of too simplistic and ultimately pointless. And so we wanted our tests to be really smart, to tell us if our player controls weren't working or if we were presenting the wrong data. And so we decided to have them more on the system test side. So our tests do the three following things. They test that we have the correct elements in the UI, that our UI elements contain the correct data, and that interacting with these elements leads to the correct result. And at this point, you could ask, well, what is the correct result? Well, our applications are dependent on a backend that serves us everything you see in the app. We actually do very little manipulation of that data in the app itself. And so we generally consider everything the API tells us to be correct. Of course, we are assuming here that the API teams that develop them also have their own tests and checks that make sure that what they give us is correct to begin with. But since we're internally responsible for them, we can be quite confident of that. And this also brings me to the fact that we, perhaps controversially, do not mock any data in our instrumented tests. We test against whatever the API tells us. And we find that this helps us basically find all sorts of different edge cases that we wouldn't have found otherwise. Of course, the data is dynamic. However, we make our tests smart so that they can handle it. And another benefit of this is that we don't have to maintain any mocks. So when the APIs update, and they do update quite often, We just have to update the code and the test code, and then we're done. There are many different frameworks that can be used to write instrumented tests. For us, what was important is that we wanted our developers to be able to contribute in writing them. And as such, we wanted frameworks that closely integrated with the apps, and also that were written in the same language as the applications. In our case, that's Kotlin. We also wanted native frameworks. And this is because as frameworks get deprecated, you will have to replace them, of course. And we wanted to avoid that as much as possible. So we were leaning towards the native ones. And we actually spent very little time choosing frameworks because of that. And we very quickly went for Espresso and UI Automator. Both of these frameworks are developed by Google, so they're considered native. They have good support from Google and from the community. They are both sort of targeted at slightly different things. Espresso is mostly focused on testing the application itself and is very efficient at doing so, while UI Automator is mostly targeted at cross-functional UI testing, cross-app UI testing. So it accesses the device itself rather than the application. So with UI Automator, you can test web views, you can dismiss system notifications that pop up over your app. But what's important for us, since we have Android TV tests, is that you can use it to simulate remote control clicks. UI Automator implements the UI device class, and you can send key commands to it that then simulate remote control clicks. Or really, there's all sorts of commands you can send. But also, you can execute shell commands on the device using this framework by sending them at runtime through the Android debug bridge into UI device. So let's look at one of our tests. Specifically, this is a test that tests our front page. Here you can see an example of it on a mobile phone and on a tablet. Our front page is quite complex. It's made up of recycler views. You have the main vertical recycler view and then nested horizontal ones that are scrollable sideways. So the navigation is quite complicated. We call these recycler views sections. So each section is potentially different. Some will have these tiles that we call plugs. So some will have titles, others will have titles and description, and others don't have any text at all. And then some are actually just a single, what we call a plug, which is serves to promote a single show on film, so those aren't scrollable at all. So the test is going to have to be quite smart when it comes to navigation, but it also has to know what to check and where. Here we have the test itself. It's actually very short, very simple. All of the logic is abstracted out. And this is so that when you are new to the code base and you come to the test, you can quickly understand what it's supposed to do. At this level, we can see that we do an API call towards our backend. And we actually use the same code at this point that the app itself uses to retrieve data. And this is because we want the same base context of what data to present. So further, we can see the method that resolves what we will be checking in each section. So the API tells us which type each section should be, and we have internal names for them. So for example, this section on top is what we call simple, and that's supposed to have just titles. The second one is portrait logo, and that's not supposed to have any text at all, etc. So we have all sorts of these sections. And based on that, we will further call a method that's going to do the checking itself. And we can see that here. So first we check that the section title is present. Again, not all will have section titles, but this one does. And then we start going through the nested recycler view sideways. And as we scroll to each element, we also check that it has the appropriate text. Now, for sections that do not have any text, we check what's called content description. And that's a field that's used by screen readers. So that way we can still validate that the correct plugs are present in the right section. At this level, there's still no Espresso framework calls present, actually. And this is because the framework itself is actually quite verbose. And we can see an example of that here. So it's not very human readable, and it's quite verbose. So we've implemented it as extension methods onto integers because we check on resource IDs, which are integers. And this also allows us in the future, if we do decide to change this framework or something better pops up, we can just very easily replace it by just changing our extension methods. And let's see if this works. We can see what our test actually looks like when it runs. So this is recorded in real time. This isn't sped up in any way. And we will now see it go through the front page and check everything. And one thing to mention is that the way the test is written to basically work with the recycler views means that it will work on any screen size, any resolution, and is extremely dynamic that way. So thanks to this test, we can be sure that if we change anything in the code base or on the front page, that it still works and still displays the right data. But also, this test works as sort of a specification. So if you're not sure what each section should look like, you can just look at the test, and it will basically tell you. Yeah, so basically it just goes on and on. So where do we run these tests and when? So we went through several options, but eventually we landed on App Center. Now, App Center has its quirks. However, it has worked pretty well for us so far. What we liked about it most is that you can trigger it through CLI, which means that you can integrate it with a range of build and continuous integration tools. So you have the freedom there. And it runs on real devices. That was very important for us because emulators are very fickle and unstable when it comes to running tests. And it's a Microsoft product, so it has very good support. We run our tests nightly and on continuous integration. Nightly, we run on a selection of 9 different devices. You can see 6 of them here. So we have a selection of various screen sizes, various manufacturers, and also Android versions. And that really gives us a proper, thorough check that our app works the way it should. On continuous integration, we run on a single device, just as a quick run-through, that everything still works as it should be. So in the end, we built up a pretty decent instrumentation test suite. Here you can see some of our results. And we are now able to focus more on unit and integration tests. The suite covers all of our basic functionality. So it's already caught multiple regressions and errors that could have caused serious usability issues if they made it all the way to our users. They do require technical knowledge to set up, and they require time to maintain. And that's perhaps their biggest drawback, because you do have to constantly go back and change them. However, they also give quick and precise feedback if something breaks. And so they ensure that any regression you introduce gets found extremely quickly, and you can deal with it there and then. Thank you.